Hi doctor, good morning. I'm Sheshatan from Group 10. Today we are going to present about our milestone 2, which is CPLD familiarization. So these are our group members, myself Sheshatan, and my fellow group members are Arun Kumar and Chantaja. So first, I'm going to present about the system overview which we'll be doing for the milestone 2. Okay, so in this milestone, a Night Rider light system as shown in the figure 2.1 will be built by making use of 6 LEDs and a CPLD. By using software quarters to web edition, all low levels modules like prescaler, BCD counter, BCD decoder, and also mapper are created, which is then being integrated at the top level schematic diagram. For that, you need to build first a BCD counter. The BCD counter is a serial digital counter that can count for 10 digits. It's called a binary coded decimal as shown in figure 2.2. So this is the BCD counter. Later I'll show you guys in the quarters web. Then we also need to do a BCD decoder, and these are the functions of the BCD decoder. I'll be showing this also in the quarters web. And this is the schematic diagram of a BCD counter connected to a 7442 BCD decoder using bus. So this will be the BCD counter that I already created in the quarters web. So you guys can see this is the quarters web and this is the BCD counter. And this will be the BCD decoder in the quarters web also. So this is the BCD counter that I built just now, and this is the BCD decoder, and this is the schematic diagram of both connected in the quarters web.
Good day to you, Doctor. My name is Arun Kumar, and I will start my presentation from Mapper. Basically, what Mapper is. A Mapper is a custom circuit that maps 10 BCD outputs to 6 LEDs. 10 input pins, 6 output pins, and 4 AND gates are used in this circuit. The 6 outputs represent 6 LEDs, and the 10 inputs represent the output of the BCD decoder. This is the circuit. The screenshot of the circuit is shown here, and this is the screenshot of the compilation, which is successful. And then this is the symbol of the mapper. I can show you that in quarters. Okay, this is the mapper circuit that we have here. And the compilation will take some time, so we'll just skip that part. Then I can show you the symbol file also, which is here. Okay, this is the symbol. The screenshot of the compilation is shown in the report itself, so we'll skip that. Okay, up next we'll move on to simulating the circuit. Based on the previously created mapper symbol, the simulation circuit is built. The mapper symbol is inserted and connected to the outputs of 7442 BCD decoder. Then the 6 output ports are added to the mapper as the 6 LEDs. The file is then compiled and a waveform file is created. All the inputs and outputs of the file inserted into the waveform file. Default end time is 20 nanosecond read size and 40 nanosecond clock period are used in this functional simulation. This is the schematic diagram of the partially completed Night Rider circuit, and this is the screenshot of the compilation, and this is a screenshot of the simulation of the waveform. The waveform figure above shows that the output changed during the positive edge of the input clock. The 6 outputs that represent the 6 LEDs proves that LEDs will be in a repeated on-off cycle, which is from A to F and back to A again, all the way to F again, and it repeats. Only one output will be low, 0 during the cycle, so only one LED will be turned on each time of the cycle. We can see that in quarters itself. Okay, this is night partial. This is the circuit, and the waveform file is here. If we set the input to count every 20 nanosecond and then simulating the output, this will take some time. This will give us the intended output waveform. Okay, this is the intended output waveform. As you can see, this is the clock's positive edge. It can be called as rising edge or positive edge. At this edge, only one output will be at low or 0. Here, B is 0. If you see at the next positive edge, the C is 0. The 0 here means that this LED will turn on. So at each positive edge, there's only one output which is at 0. Let's see here. Okay, for this, only D is at 0. So only D will turn on. Okay, this is for the waveform of the simulation circuit. Up next, we'll move on to prescaler. A prescaler is an electronic counting circuit used to reduce a high-frequency electrical signal to a low frequency via integer division. Prescalers are typically used at very high frequency to extend the upper frequency range of frequency counters, phase-locked loop PLL synthesizers, and other counting circuits. The prescaler module slows the clock from 50 MHz to exactly 1 Hz. Okay, in our milestone, a Verilog file is created with the provided code in the manual, which is then compiled to obtain a prescaler symbol. Then the prescaler module is added into the partially completed circuit earlier between the input port and the BCD counter. Okay, this is the code that has been provided. A Verilog file is created from this code, and then we compile it, the description of the compilation. And then after compiling, we created a simple file, symbol of prescaler is as shown here. And then at last, the schematic diagram after adding this prescaler into the circuit is this, where we add the prescaler in here between the input and the clock. I can show you that in Quarters itself. The night final. Okay, this is the circuit. Okay, we'll show the prescaler first. Okay. This is the Verilog file of the prescaler, and then the symbol of prescaler is here. This is the symbol of prescaler. And then this is the final circuit, the schematic diagram after adding the prescaler into the night partial circuit, which is in between the clock and the input. Okay, thank you. That is all from my part.
Hello doctor, my name is Chan Tai Jie and I'm responsible for programming the CPLD. First, you need to go to Assignments, Device, the family is Max2 and make sure this chip is selected, press OK. Then you go to Pin Planner, declare pin 64 as the GCLK and input tri-stated 74, 6, 8, 82, 4, 6 as A, B, C, D, E, F and all of them as output driving VCC. Then you need to recompile the design. Then you need to program the chip. Make sure the USB blaster is selected. Then add file, go to the output files and choose this POF file. Then you check this program and verify. Then you press start. After successful uploading, the LED should show a pattern like this. Thank you very much. That's all from me. Bye bye.